What up, everybody? Welcome to the channel. OSI model, I feel like, is a good starting point, so we're just gonna dive right into it. If you're thinking about getting into IT, networking, cybersecurity, or just studying for something like the CCNA, CompTIA's Security Plus, CompTIA's Network Plus, someone's gonna throw the OSI model at you eventually. Something you have to learn, theoretical model, it's gonna be there your entire IT journey. And when I first learned it, I thought, cool, 7 layers of something I'll probably never use in real life. Honestly, kind of true, but also not really. You're not going to be walking around the office saying, wow, sounds like a layer 4 issue. But what the OSI model does do really good is give you a troubleshooting roadmap. When something breaks, it helps you mentally work from the bottom up. And when I say bottom up, I mean the entire network stack. So we're going to break down all 7 layers without making this feel boring. That's the plan anyway. Starting off at the very bottom is the physical layer. This is your actual hardware. This is the fun part. This is your computer. This is the NIC in your computer. This is the switch port interface. This is your fiber interface. This is your fiber cable. You'll hear a lot about RJ45 and all the different types of fiber connections. You got, name a couple that are still very relevant out in the world are your LC fibers. I don't even know what LC really stands for. I call it little connector, and you'll understand why when we get into that later. A lot of ST fiber out there, stick and twist. Not sure what it really means, but that's what we call it. All of those are fun, tangible items you can get your hands on. Now, one thing you'll hear about fiber is the bend radius. You got to know that. That's on the exam. You cannot bend that too far. It will snap inside, and if that breaks, you are donezo. I've been working in the IT industry for over 20 years now, and I can't tell you how many times I get a call, frantic email that we're having a huge network outage. Turns out someone literally unplugged one thing. That could have been a router that's connected to the backbone of your network, so now your partner out there can't communicate on your network. Could have been anybody, could have been your help desk, could have been you. You could have been patching something in, bump a wire, and maybe that RJ45 connection didn't have that little clip thing that we all love. Those break off, people don't replace the cable, still falls out, you have a problem. My suggestion right there would be, if you break the clip on a Cat5 cable, Cat6 cable, just replace the whole thing. Don't wait for that headache to bite you at 2 in the morning. You do not want that. Fiber is really fun too. I've had situations where on the LC connection, I had to, if you don't know what a fiber looks like, let me pull it up right now real quick. Let's do LC fiber. Here is a picture of some LC fiber. We have one side that transmits, one side that receives. And when I'm talking transmit and receive, I'm talking literal light shooting out like lasers. So this could be the transmit, and this could be the receive side. Sometimes these need to be flipped. So if never look directly at this, okay? You'll hear that too. Fibers, light, that is like a laser that'll go right into your eyeball, and that can't be good. So everyone has a smartphone these days. Pop your camera on. You don't have to take a picture of it. Just pop your camera on. Put this directly in front of the camera lens, and you will see that coming out. Now, you'll have to look on the other side, which we will get into later, is called SFPs. That's what lets this connect to your switch or router. That will also shoot light like lasers out. You have to look at that too, because if the SFP is here and on your transmit side you also see a light, well, that means you got to flip, because light goes into no light and the reverse order too. If you have light coming out of your switch, it has to go into something available, and it can't be optical lasers shooting out. It will not work. It'll never connect, and in your switch config or your router config, it'll just stay down. But getting back to just regular, what you'll probably deal with the most is just your regular cables, your RJ11s, your RJ45s. So at layer 1, when troubleshooting, very rudimentary, is it plugged in? Is it seated all the way in? Do we have link lights after we plug something in? Got to look for all the little things. And believe it or not, layer 1 is your wireless signals. Your computer has or your laptop, just make it easy, it has a wireless NIC in it. Now that's going to communicate to your access point hanging in the ceiling. If you're at home, it's probably going to connect to your router because usually they're all in ones. But believe it or not, that wireless signal is layer 1. So be aware of that. The last thing I'll say about layer 1 is we refer to layer 1 as bits on the wire, sending bits over the wire. Now, on the left-hand side of this OSI model here, we see bits, frames, packets, segments, and then 3 data. For the CCNA, for the Network Plus, you have to memorize that. I hate to say it, but you have to. So just drill into your head, bits, frames, packets, segments. That did come up when I was taking my exams. It'll make a lot more sense later once we move up the model here, and actually later in life when we dive into the concepts. So for now, please, bits, frames, packets, segments. Moving on to layer 2, we have the data link layer. This is the MAC address layer. If you can remember that, you'll be fine. And MAC addresses are transmitted through frames. Frames are not IP addresses. MAC addresses are the burnt in address of your NIC. At layer 2, devices use MAC addresses to communicate within the same local network. Switches read these physical addresses to forward Ethernet frames to the correct device on the same LAN. Once traffic needs to leave the local network and reach another network, that's where layer 3 comes in. IP addressing comes over. But for layer 2, you can have a switch on the same network. You can have, 48 other PCs plugged into that switch. I say 48 because that's how many ports are in a regular 1U switch, and they could communicate. The switch will generate a MAC address table. Now, you don't program your computer or your printer with a MAC address. You just use IPs. As long as they're on the same network, they will communicate. But for exam purposes, you will need to know layer 2 is MAC addresses and is transmitted via frames. Other than MAC addresses at layer 2, we have VLANs that live here, trunk ports that live here, spanning tree that lives here. This layer controls how devices communicate inside their local networks. This is where I spend a lot of my life. Wrong VLAN assignments, trunk ports, missing VLANs, spanning tree weirdness, MAC address table issues. This layer is where the most happens. This is where you will spend most of your troubleshooting, and that's okay. You'll learn to love it. You'll learn to understand it. We will bust out Wireshark eventually, and I'll show you what a frame actually looks like. I will make another video of my GNS3 lab where I can connect a bunch of devices to just one switch, and I'll show you exactly how layer 2 works. Layer 3 is network. This is where IP addressing and routing happens. This is where routers come into play, make decisions where traffic goes. Default gateways live here. Static routes. This is where we get into concepts like OSPF, which is dynamic routing, BGP. This layer answers, how do I get traffic from one network to another? That means when you set up a network at home, I only mention home routers because If you're just trying to break into the industry, you probably haven't seen an enterprise router, which handles multiple networks. What a network might look like at your house is when you plug in your router that you just, got from Best Buy, got off Amazon, wherever you got it, you'll probably start with the network address of 192.168.1 dot whatever, 192.168.0 dot whatever. In almost every case, your router IP address is going to be 192.168.1.1, right? That's going to be your default gateway. That's going to be when you plug in your printer, you're going to give it an IP address of 192.168.1.10. Your computer might have 192.168.1.11. Now, after you get all your devices plugged in and you're on that 192.168.1.0 network, I'm going to say /24 because that's the CIDR notation for your subnet mask being 255.255.255.0. That means you can have 254 devices on your home network. Now, in an enterprise environment, you have more than 254 devices. Now, on an enterprise network, you're going to have multiple networks. For example, you might have a network that's 192.168.1.0/24 and another network that is 192.168.2.0/24. Now, if those are both /24s, that means that's two separate networks. Without routing, without layer 3 default gateways, then your traffic will never talk to each other. Now, your computer might be at 192.168.1.50 and you want to print something on 192.168.2.10. That's why we need layer 3. That's how they communicate. And I will demonstrate all that in a later video. I've seen it where at layer 3, somebody had IP'd a workstation for 192.168.1.50 and put the subnet mask of 255.255.254.0. This isn't uncommon. People make mistakes all the time. And they were still able to communicate with another device on that same network. At layer 3, we see the word network. It's kind of misleading. A network is just a broad term for a place where all our devices are connected. A subnet, which you'll hear more of, it's actually just short for subnetwork. It's a smaller division of a network. And we use subnet masks to keep them separate. Once you break into the industry, you'll hear people in conversations say things like, well, what network is that device on? What they really are talking about is what subnet or what VLAN is that device on? And when you're at the same organization for a while, that will make a lot more sense just because certain departments might have their own IP address scheme. So just by knowing what network it's on, you might know where a device lives or what part of the building that device is going to, or where you have to go to fix a device. The last thing I want to mention about networks is you'll see the media type for that is a packet. We're working our way up. Bits, frames, packets. Packets is, again, in Wireshark, we'll be able to break that out and show you everything within a packet. You can Google what an IP packet looks like. It has a header in it. It has where it's going, where it came from. And this just helps us get data from point A to B. As we move into layer 4, the transport layer, that is TCP and UDP. I'm going to switch pictures over here just so you guys can see the little graphic. TCP is our reliable protocol. That's how a majority of the traffic is being sent. UDP is for speed, and I'll dive into both briefly. TCP, I said it is reliable. It starts off with a handshake, the TCP three-way handshake. This is something you will need to know when taking any exam. And the thing to remember is SYN, SYN-ACK, ACK. SYN is SYN. Client says, hey, I want to start a connection. Then we have the SYNAC. Server responds, got it, I'm ready to. ACK, client responds, perfect, let's communicate. Now, that is something we will see when we break open Packet in Wireshark, and I will show you exactly what to look for. This will help you solve a majority of your problems. Knowing the three-way handshake is a great troubleshooting concept to retain for when we break into Wireshark. If the three-way handshake doesn't happen, then communication won't start, and at that point you can double back and figure out why that's not happening. Hopefully I'll be able to get some examples of it not happening, and then we can fix it. As I said, TCP is reliable. That means it tracks the packets and retransmit any data that might get lost. Now, when you're browsing the internet, there's a lot of devices in between the website you're browsing and your computer, and anything can happen in the world. Now, why TCP is reliable, UDP, I don't want to say is unreliable. It serves its purpose, but when you have TCP reliability, you are not sacrificing speed, right? Everything happens so fast, but things could take longer. UDP does not care. UDP is about speed. And where do you need the speed? When you're on a phone call or watching a video, that server is just sending data without even thinking about it. I'm sure we've all heard it, been on a call where the user might sound a bit robotic or cut out for a second. That's because UDP probably dropped some packets, but it's just going to keep sending. As that person keeps talking, those packets will keep flowing. You will still probably be able to understand the person. If it's real bad, you might have to have them repeat, but unlikely. Also, why when you're watching any type of streaming service and you might see the resolution, I don't want to say it goes blurry, but it goes down from maybe your 4K down to 1080. Things to keep in mind at this layer 4 TCP UDP ports like 443, which is your HTTPS port 80, your regular HTTP. Hopefully we don't see much of that anymore. Port 22, your SSH, and your port 339, which is your RDP. Those are very common at this layer. Definitely something you will want to keep in mind if going for any type of certs. We'll see a lot of these ports and protocols in the security side of things too, which we'll get into later. Layer 5 creates, manages, and tears down conversations between applications. Think of it like a meeting coordinator of the OSI model. It makes sure the two systems stay connected long enough to communicate, but it also knows when the conversation is over. A quick example of that would be if you log into a remote desktop session, join a video meeting on Zoom, Teams, whatever it may be, it maintains that open connection. Once the meeting is over and you click end, layer 5 knows, tears it down. Just try to remember, layer 4 moves the data, layer 5 manages the conversation. Layer 6, the presentation layer. It translates data so different systems can understand each other. It handles things like encryption, compression, formatting. Some real world examples just to let it set in for you. Encryption. When you visit a secure website, you'll see HTTPS, also known as TLS, port 443. Layer 6 helps encrypt your data. So when you go to websites like Amazon or financial websites, your banking websites, layer 6 is handling that encryption to keep you safe. Also does compression for things like streaming services like Netflix, so the videos can load faster. It does formatting and translation, converting file formats like JPEGs, MP3s, ASCII, Unicode, JSON, etc. We're not going to get into the formatting and translation too much. Just know it's there. You're not going to see it in your day-to-day if you're working just regular IT, networking, security. If I can give you one way to remember layer 6, it's like a translator and a security guard combined. It makes data readable for the application and protects it before it gets there. If I send you an encrypted file and your computer decrypts it so you can open it, that translation process happened at layer 6. Layer 7 is the application layer. This is where your users directly interact with network services through the applications they're using on their PC. They will be popping a browser open using HTTP, HTTPS. They'll be using DNS without even knowing it, SMTP, and FTP. Well, hopefully no one uses FTP anymore, but it's part of the layer. Some examples to help you remember would be if you're browsing a website, HTTPS. As an administrator, if you're looking up a domain name that's using DNS, sending emails through Google or even Outlook, that's SMTP. Uploading files, a lot of FTP, SFTP, hopefully no one uses FTP like I just said. Streaming music on Spotify, that's all layer 7. That's where that interaction happens. Layer 7 is the applications that your users see. This is where they're going to make requests that go through the entire stack, and they don't even know it, but you need to know it. When you type google.com in a browser, layer 7 is where that request begins, but all 7 layers work together to make that connection happen. Now, once people finally memorize the 7 layers of the OSI model, they usually learn something slightly annoying. The internet doesn't really use the OSI model exactly the way I tried to explain it. That's where the TCPIP model comes in. The TCPIP model is more practical. It condenses things down into 4 layers, and it better reflects how modern networks actually communicate. We won't spend a great deal of time going through the layers again. I'll be brief. The first layer is network access. It combines layers 1 and 2. So physical hardware, cables, switches, MACs, wireless. They all get grouped together. The second layer we call internet. It maps to OSI layer 3. This is IP addressing and routing. Routers decide where the traffic goes. ICMP, ping, trace route, all that fun stuff. The third layer, transport. Pretty much the same thing, just renumbered. TCP, UDP, and some ports. Reliable versus fast communication. Nothing has changed there or added. The fourth layer is the application layer. This combines 5, 6, and 7. Sessions, encryption, applications, protocols like HTTP, HTTPS, DNS, SFTP, all lives here. So why do we even learn OSI? OSI helps beginners understand networking in a more detailed way. It breaks down things into smaller chunks. TCP/IP is more realistic. OSI is more educational. Think of the OSI model as learning anatomy in medical school. Think of TCP as actually treating patients in real life. One is deeper theory, one is practical execution. And in real world IT, you use both. For example, if someone says the website's down, I'm immediately thinking, is it physical? Is the switch okay? Is routing okay? Is DNS broken? Is a firewall blocking something? Are specific ports blocked? That mental troubleshooting path comes from understanding both models. And that's why this stuff matters. Don't just memorize it for the certification exam. Actually understand it, because eventually production breaks at the worst possible time, and this will help you have some sort of roadmap to figuring it out. Eventually, when you start troubleshooting, you might see repeat problems, and you won't have to refer to this as much because you'll just know how to fix certain things. It's for when you get those problems that no one's seen before, or it's just your first time seeing it. At least you'll have some understanding on how to get a solution in the end.